Hello, everyone.
Good evening.
How are we?
Doing well here. Doing well. How are you?
Not bad, thank you. Uh, Ready to kick off
Mm.
our fourth week. Hopefully, our audience haven't had enough of us and they still enjoy.
Yes, true that. True that. Awesome. Well, hi everyone. Welcome to week 4, module 3. It will be a fun one, as you already know from the other ones. I hope the uh, discussion questions that we're sharing are actually going well for you, and you managed to get like a little bit of a grasp of how the questions might be at the exam. You also should have access to Google Cloud Skills, or Google Skills now called, where you'll be able to go through the professional cloud architect path over there as well for training. For anyone that do not have yet access, but you have registered within the last 24 to 48 hours, please do give it a couple of days as well. And if you still have an issue or still have not have granted the access, you can always email us to this email address, and then we'll be able to raise it with the relevant parties. But uh, recording is already on our page. So if you navigate to, I'm just going to share it now, the link. If you navigate over there and go to the past ones, you will see the recording embedded in the page if you scroll down onto the page. So you will see the week 1 and 2 recording over there. For any other questions, please do email us. With that, you probably know what will be my next sentence, and that will be, we have a lot to cover today.
Good. Yes.
We
Um,
have,
and
yeah,
as usual, we're going to try to cover as much as possible. Obviously, we don't want to go through it so you won't understand everything. So we'll stop here and there just to explain a few concepts. But if, as usual, if you do have some stuff that we haven't had the time to go through it will be your homework.
definitely, yeah. It will be an additional homework. So with that in mind, after the session, we'll share the slides. Then we will share a couple of more details as well after the session. That is, we will share the answers from the last week, kind of like questions that you had over there. So you'll be able to validate. And then also we will share the questions from this week. It's kind of like a workbook when it comes to mind. Now, without further ado, right, I will kick it off today. Sorry, you're still stuck with us, right? I will kick it off, and then Stefan will handle the part 2. Now, before I start, just to let you know that there is a slight changes with the last week's session due to unavoidable obligations between Stefan and I. The session will be on Monday instead of Tuesday, but we will update the um, event post or event page. We will update it with the new timing. Therefore, when you register, you will receive the confirmation and when is that happening. So, but uh, no, no afraid, right? We will be able to cover as much as we can over there as well. Now, let's kick it off. So, welcome to Module 3, which is Designing for Security and Compliance. For anyone that's worked in the, most likely like in the hospitality industry, which is like a big one, if you need to handle any of customers' data, right? Not just hospitality industry, but mainly over there when it comes to payment card industry, there is a couple of details or need to mind when it comes to compliance, but that is one of them is that, well, we need to design for security, right? Security first, but also be compliant with the regulatory. With that in mind, what we're gonna cover today will be how we can map PCI DSS, which is payment card industry, right, to GCP. Then we will go a little bit more details about Kubernetes engine, Google's Kubernetes engine, Cloud Run, which is serverless solutions on GCP, And at the end, it's the EHR healthcare case study analysis. Now, as Stefan mentioned, we might not be able to cover everything today. However, it will be able to share, and everything that's within the slides when it comes to link, you will be able to go through them at your own pace. So our focus today is security compliance, right? So let's see how we might think about when it comes to SimpleDirect. So when we explore the role of a professional cloud architect in designing any Google Cloud solutions, we need to meet, for example, when it comes to SimpleDirect, but any other customer, we need to meet the requirements for security and compliance. An architect, when designing a solution, may have like a business, where you have the technical requirements that are specific to security, they can be specific to compliance. So if we are designing any solution to a financial institution, we will almost certainly be the case where we need to meet any regulatories. But for most companies, right, security is going to be the integral aspect of, well, the integral to all the aspects, not just integral aspect. It will be integral to all the aspects of our design decisions. You might have noticed a little bit of a pattern when it comes these couple of weeks, and because what I want to actually grasp over here is that the case study, when we have for the exam, you will always have the business requirements, technical requirements, and executive statements. That is because it is not too far of real world scenarios. When it comes to real world scenarios, you have the technical requirements, right? However, you will have a business requirements, which means that, well, we have only so much CapEx, right? We have so much capital expenditure that we can have. So we need to design a solution having that in mind. What does it mean is that, well, if we have a more capital expenditure, right, and like that, we can think from the beginning of how we can integrate that with different products. But if we don't have, and it's more on operational expenditure because we want to, move it down the line, then we need to have those couple of things into place. So in our design decision, right, it isn't just like, we need to properly configure, for example, like network firewall. We need to think about all those kind of details. So we need to follow Google's best practices when it comes to security, but that is no matter what type of solution or resources we'll be using. So, for example, we should always, if we go back to Compute Engine and VMs, we should always kind of like prefer or prioritize deploying VMs without external IP, which means that we will follow the least privilege approach. But if we have specific requirements for compliance, because we are working with a sensitive information like financial or medical data, so we need to handle those different types of regulation. So when it comes to like a SimpleDirect and their requirements, there is a kind of like a straightforward right over there. We have several users. They're going to have several types of levels access. Some will be employees, others will be customers. So at a better baseline, when we will design this, we might want to make sure that we expose services as little as possible, at least privilege. And then when a service is accessed, users can only access what they need and nothing more. So this is the principle of least privilege. We all know that when someone would kind of like log in, right? We're talking about over here about authentication, but then we have the authorization part, which means that the authentication is us proving who we are, but authorization is actually proving what we can access to. So SimpleDirect in this case, it's not a bank, it's not a healthcare provider. So we have a fewer compliances. However, we'll need to meet some level of requirements, right, when we are going to architect all this. So, well, apart from us, right, Google as a company, right, needs to deals these kind of like compliance regulatories, what we all need to, right? So Google offers tools on GCP where you can leverage to meet compliance requirements. So if we're talking about compliance requirements, in short, right, GCP has like a ton of different regulations, and it undergoes regular like external audits. So, for example, that the platform is compliant for PCI DSS, GDPR, HIPAA for the healthcare in the US, and others. So now, when we would deploy solutions to GCP, right? So are those compliant? So, for example, when we deploy them, when we deploy those solutions, we straight away need to think, well, are those solutions like straight away, like the system that we deployed, are compliant as well, and why? So, what would you think, right? Are they like compliant straight away? So, apart from like compliance, Ian, I have noticed in the chat, Ian said the helicopter racing case study is no longer used. Yep, it is no longer used. However, it is included over here as a practice, right? So keep in mind, over here, like during these kind of like a case study weekly that we have, the main thing is for you to get like a practice, right? So always follow the last certification details on the Google Cloud Docs to be able to be up to date on anything. So awesome. So if you continue on that, right, apart from compliance, please note that also the exam will be actually focused a lot on security. So even if like, for example, on the exam, we will have some questions that mentions like one of the compliances by name. So there will be also more information, like it will not say in the exam that you will need to comply with GDPR, but it will also translate it to the technical term. So for example, you might be asked, how would you design this or that by making sure that your data stays in a specific GCP region, right? So straight away when it comes to that. If we go further, on those ones, right, is that we mentioned like HIPAA, FedRAMP. So FedRAMP is also in the US and stuff. If anyone has ever gone through actually the most kind of like the most rigorous one, like I went through the CISSP from ISC2, ISC squared, whatever we want to call it. That one is very heavily on these kind of details. So any kind of like a security exam over there, it will ask for you to kind of like follow or know these kind of compliances, because at the end, all companies, whether they are what kind of data they are actually processing, they will need to comply with all this. So how do you ensure compliance, right? So we should always focus on security, but when it comes to like a security service, right, there will be no single or like a global security service. So what we need to do is we will need to increase or decrease the security posture of our solutions when planning each part. So for example, when we need to decide between standard and shared VPC, when we need to decide about using Cloud Armor, how users will SSH into VMs, and so on. So for example, like what would be like, well, when the users will need to SSH into VMs, what is the best, like we don't want to have it, for example, a certain server that is not actually needing to have a public access and it just used internally. We don't want to have it exposed. So what we're going to do, well, we can do SSH via Bastion host, for example. So if we want to understand better, right, how Google like thinks on higher security level, there's a couple of over here like security solutions, I would say, such as like I mentioned Cloud Armor. There is a IAP, which is Identity Aware Proxy, Resource Manager, the serverless VPC access. That is very important when we want to connect any serverless solution like Cloud Run, for example, and etc. So how we will be able to, or how we can map the PCI DSS requirements to GCP. So first one is just an example, right? So let's just have a look about like kind of like a firewall rules. So if you look at a firewall rules, so for example, when we use a shared VPC, we have like a VPC peering, and there's like some rules between them. So we really need to, when you think about architecting solution and stuff like that, we need to take a step back, and first we need to isolate the systems that will be in scope for PCI, for example, and we will need to isolate it, for example, by using projects, by using VPC, etc. And then, if you need to think about further, we need to connect those ones appropriately so they can communicate with each other. So that is kind of like a first step what we need to think about. Second step, right, is that it's kind of like a having it out over there, is that if we do, for example, default VPC plus subnets plus firewall rules, we do default service accounts, OS images, and default way of SSH into like a VMs and stuff like that. So do we actually, right, need to use like a vendor supply defaults? So how do we do that? How do we actually impose those kind of details? So for example, over here, if you see, we have like a base image, which will be like a hardened image with unnecessary packages removed, right? So vendor supply defaults, if we will have any, we need to tweak them in order to be able to be compliant with PCI DSS. When it comes to our packages or the libraries that we use, if they are not in compliant, we need to think about how we will be able to deploy them. But the most important bit, right, why we have PCI DSS is that how we can actually protect that data that is stored over there. So PCI, when it comes to like requirements, it talks about, so one of the requirements talks about encryption and rest. So when it comes to encryption and rest, there is a couple of options on GCP we can do that. So one it can be is that we have, like for example, Google encrypts all data at rest. So with no configuration done by any customer, all data on GCP is it's encrypted, right? So data at rest is encrypted. So, but in some cases, we might want to add additional controls over encryptions for kind of like multiple reasons. But some of those reasons, for example, that be like, well, when we want to add it, right, we can also use two approaches over here. So some of us, or like a solution, we want to use maybe customer managed encryption keys that we mentioned before. That can be by using like the Cloud Key Management Service. So with this one, we can define encryption keys. We can like establish like a rotation policies, etc., etc. But also we want to use the customer supplied encryption keys, right? So just supplied in some Google services. For example, this can be used in Google Storage, Cloud Storage, whatever you want to call it, in which Google is no longer, right, the root of trust. So customer supplied encryption key, it comes with like a little bit other risk of data loss, because if we lose the encryption keys, Google doesn't have it, right? It's not actually customer managed, it's customer supplied, which means that it cannot help to decrypt that data if we lose the encryption keys. But yeah, so there's like when it comes to like a customer managing customer supply, there's another thing as well, is that we also do not have to choose one key management option only. We can make like a use of the default encryption for most of our workloads, which will meet those regulatory requirements. But also we can add like some additional control for selected applications, stuff like that. So those are like when it comes to the requirement 3, when it comes to protect, but also we also need to first identify, right, what system will contain PII or personal identifying information. So how we can do that? So for example, one of the requirements in PCI DSS, right, is that a primary account number, right, must be unreadable anywhere it is stored. So that is like one of those ones. We can use the if you want to have like which system contains PII, it's, as you mentioned over there, is we can use the Cloud DLP, which is like a data loss prevention. So we can use that like a using service as well for remove sensitive information when it needs to be used by other systems. So a very, very, there's like a lot of, in the docs outside there, is that when we use a BigQuery, right, for example, analytics in BigQuery, you can also have those data redacted because you want to use for analytics, but you want to be also compliant. So you just like to be readable over there. So if we're talking about the primary account number, right, or PAN, so although Google like automatically offers that encryption at rest, right, it doesn't automatically does the one-way hashes. So one-way hashes. So what does it mean is that the tokenization, right, that is like the rules also require, it needs to be done. So we would use data loss prevention for truncation and tokenization, or we can use just like the key management service, for strong cryptography with managed keys. So there's a couple of like, you probably notice a little bit of a pattern over here, is that anytime we would have any details or anything that we need to use, there is a multiple approaches that we can do. That is because GCP is very big, very robust, and there is kind of like a no one way fits all, right? It can be done, it all depending on those ones. That's why we're here, because we want to be the architect when it comes to that. Going forward, right? So we covered details about encryption and rest. But apart from encryption rest, right, we have encrypting data in transit, right? Data in transit, but there is like for example, across, as you mentioned over there, across open and public networks. So another requirement from PCI talks about actually encryption, like, so basically the cardholder data across open and public networks must be encrypted. So when it comes to GCP, if we're talking about TLS, right? So any data sent to any like a data cloud service is encrypted by default using TLS. But once inside Google, what happens to that data? So for example, Google encrypts and authenticates that all data in transit because it has like a one or more network layers. So when data moves outside the physical boundaries, not controlled on Google, which is like, or on behalf of Google, that is like have it like encrypts and authenticates all the data, and data in transit inside that physical boundaries that we're talking about inside the GCP network, right, is generally authenticated but not necessarily encrypted. So although it's not, we still compliance over there. So we also have like a couple of data, or like we see it over here. We have like HTTPS load balancer as well. So we can also use that to encrypt incoming customer traffic. I think, yeah, it mentions, if you see over there, VM to VM, Istio as well can be used to secure traffic between VMs. Cloud VPC, for example, can be used to establish a secure VPN tunnel between on-prem and the payment processing environment, whether that will be, somewhere else. A lot of time, and this is kind of like from my approach in the real-time world, when you would need to architect some solution and you would need to meet PCI DSS and stuff, sometimes this also depends, right, on the your business and technical requirements, but most of the times you would offload the payment processing into like a outside in like a different environment. What does it mean is that instead of us creating that payment processing or whatever it is, right, we would offload that by using any of like payment processing solutions out there. What does it mean is that they're already compliant by, for example, storing the PAN, storing customer data, because there's a couple of other things as well you need to meet over there. For example, the customer cards, they cannot be stored, I believe, only like a last bits, but then expiration date must be stored. They all must be encrypted at rest and stuff like that. So which means that we don't worry a lot about that over there, but we need to worry between like the communication from outside our side, like anything that lives on GCP to the payment processing environment. So for example, like we can use the Cloud VPC, we can have like a VPN tunnel, etc., when it comes to that. So how do you restrict access to sensitive data and in GCP, right? So another requirement for PCI compliance is that you will need to limit access to system components and actually like a cardholder data to only whose job requires such access. So what does it mean is that only the ones that must actually be working with those details on a daily basis should have access. No one else is kind of like allowed to, right? So we need to define access needs for each role. So for example, we need to have a role that each role needs to access for, like, for example, their job function. List of privilege is over here. So for example, what will be the user, will be an administrator, etc., for accessing those resources. We need to have a privileged user IDs, for example, when we need to perform the necessary job requirements. And this needs to be covered across all system components. And we need to have, so if we go back a little bit on the identity and access management, we must always have those that default deny all, right? So default deny all must be there so that we will deny all apart from the ones that need to have access. So the assignments, like for example, of those privileges to individuals, they can be based on job classification and function, etc. So for example, if you see it over there, if there's like a couple of details about App Engine Admin API. So for example, the role to upload specific SSL, deletes, gets, etc. So the API Explorer, which is on the link over there, you'll be able to access it as well once we share the slides. You will be able to review those available permissions, and according to PCI requirements, you should be utilizing to limit access to system components to only those ones that are requiring. Now, the last bit that we will talk about today about the requirements on PCI is that how would you go about monitoring different events, for example, network traffic or accessing cardholder data? So one of the PCI requirements talks about tracking and monitoring all access to network resources and cardholder data. So in GCP, there are many logging options available to help us achieve this. For example, if there is like any VM instances running a logging agent, we'll be able to do that, etc. But effectively, what we need to answer to those logging requirements is that who or what acted, right? Who or what did what? Where did they do it? When did they do it? Stuff like that. But apart from that, in GCP, right, we also can expand, right, and stuff like that. That we have audit logs over there, which are available, and they will be able to generate two type of logs: admin activity and data access. If we take an example of one of the resources in GCP, for example, BigQuery, we can have an admin reports in BigQuery. So basically, we can export those ones in BigQuery, and we'll be able to query those one additionally as well. So when we're talking about GCP, right, it's all about logging and gathering of those like telemetry data. A lot of different ways, like admin console, cloud audit logs, network logs. Stackdriver is no longer called Stackdriver, right, on those sites. So yeah, but there's like a lot of details that we talked about it. But the most important thing is that we need to be able to track who or what did what, or what acted, where did they do it, and when did they do it, at the minimum over there. Now, so cool. So I hope that was like a little bit of a useful details, having like a PCI as an example. So it will hopefully help us to like learn a little bit more about compliance in GCP, and this will help us more to be able to distinguish those technical and business requirements and translate them into any solutions on GCP. Now, we're going to switch about a little bit to JKE, or Google Kubernetes Engine here. So this one is very important for the exam. As you're probably aware, the exam is, I don't remember how much of percentage was, but you will probably see it over and over, like quite a few times. So, but although it's a lot like used in the exams, it's not very covered in the online learning. Like, for example, well, it's a lot covered in the docs as well, but it can be quite a lot of to grasp. So we'll spend a little bit more time, right, when it comes to like this topic. So if you see over there, there is an exam tip, which means that the Kubernetes concept is very, very important to be familiar. So the slides, over here will give us like a little bit like a high-level overview, but we need to be very comfortable. Well, we need to be comfortable with it when it comes to during the exam. So autopilot mode, what does it mean? So that means that the Google Kubernetes Engine will manage the whole underlying structure of the cluster, including the nodes. So previously, if you have actually noticed like that previously the exam was not having like autopilot, but it was updated as well to have like autopilot as well. So when it comes to like a standard GKE clusters, you need to know quite a bit like about the options that are available over there. So one of those ones will be autopilot mode. So when it comes to like clusters and Kubernetes engine, one thing to note over here, right, is that we need to be able to distinguish or make decisions about the infrastructure and actual the settings behind it. So if we're talking about, you have an example, like if we have the exam asking about, like if you see over here, that will be managed like underlying structure of the cluster, blah, 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 statelets, stuff like that. Then we'll be like, might be like autopilot mode or stuff like that. However, what if we go a little bit different? Because, Google manages our cluster. It is the recommended way. So two things right over here is that when we will go for like, when we will go to go through the exam questions, make sure to note on the keywords. So sometimes you will be like, what's the Google's recommended approach? If you see it over here, right, on the screen, it says like autopilot, Google manages your cluster, and it's recommended. So those are like a couple of details as well to note when it comes to the exam. Now, you might see as well like on the exam like a question or two about the concept, like for example, that we see over here, like a pod disruption budget or readiness or liveness probes and stuff like that. So what this all mean is that all these like allow us to keep our application healthy and available, even if you're updating, for example, to a newer release. So when we want to quickly replace one version with a new one, so for example, being quick might be important, but it's also very important to still have our application running while it's being updated. So this is where we should need to be familiar with these concepts. So in the exam tip, if you see like on the bottom of the slide, you will find over there links to actually kind of good explanations. So make sure like you go through those details as well. Now, we won't be able to go through like a lot of them without having some diagnostic question discussion, right? So let's go through it. Your company has an application running as a deployment in a Google Kubernetes Engine cluster. When releasing new versions of the application via rolling up deployment, so we're releasing via rolling deployment, right? The team has been causing outages. So the root cause of the outages is misconfigurations with parameters that are only used in production. So you want to put preventive measures for this in the platform to prevent outages. So what would you do? Configure liveness and readiness probes in the pod specification. Configure health checks on the managed instance group. Create a scheduled task to check whether the application is available, or configure an uptime alerting clock monitoring. So what would you do, right? So I'll give you like a little bit of a help as well over here. When it comes to like Google Kubernetes Engine, do you think we are using managed instance groups over there? So it says B, everything is A, forget to update them. B, it says configure health checks on the managed instance group. Do we deal with managed instance groups in GKE? A, all right. Someone says first as well. A, all right, cool. Yeah, so C, it says create a scheduled task, right? So with that one is not like a JKE tool, right? So does not use that, and not the best option. But D is configure an uptime alert cloud, but that one will alert us, but will it actually be able to resolve that, right? No. So yeah, so configure the right liveness and readiness probes, prevents outages when rolling out a new replica set of deployment, because pods they're only getting traffic when they're considered ready. So this is where we need to go and do the check. So this will lead us to the best practices, right? So we'll see a couple of best practices when it comes to JKE upgrades. So one, we need to set up multiple environments. So we need to have a pre-production and production cluster. This is mostly like available, right, across everywhere. We need to enroll clusters in release channels. Continuous upgrade strategy. We need to have scheduled maintenance windows and exclusions. And we need to also set tolerance as well when it comes to this. So a couple of best practices regarding like upgrades, but these are mostly they're mostly at infrastructure layers. They're mostly self-explanatory. So what does it mean is that they are, easy to remember. So let's move forward, right? When it comes to controlling access to our clusters, right? We can use identity and access management, and actually like a best practice would be, is that we would use identity and access management at a project level. But if we have different groups of developers using different namespaces or clusters, that's why we need to implement identity and access management with role-based access control. which is the Kubernetes native way of managing permissions. So a little bit of an exam team on the bottom as well is that mentions that identity and access managers and Kubernetes role-based access control work together. So a little bit of an exam tip over there. Now, JKE Sandbox is something that we need to understand on a high level when it comes to the exam, but this is just mostly to identify its use case. So what this feature does, basically, it prevents the untrusted code from affecting your kernel on the VM level. So if we need to use a Docker image, but you don't trust, so for example, we're using one from a third-party provider, it's best if we use this additional kind of like a prevention mechanism. So we'll use it in Sandbox. So the JKE Sandbox, it does provide that extra layer of security. So it will host the kernel, to prevent the untrusted code from affecting the host kernel. So what does it mean is that, like we mentioned, if there is like any Docker or container, it provides some, when we need to host them, but it's like third party, it will provide some degree of isolation between the containers processes and also the kernel which is running on the node. So yeah, those are a little bit of details. But networking, because structurally right, it's always like part of that. So when it comes to, well, I want to say when it comes to like, Kubernetes Engine networking, but also like networking in default, right? It can be like very, very complex because we can have like hundreds or thousands of IP addresses, and if we don't explicitly plan the size of the clusters and the pods that we'll have, so we will actually kind of like waste those, right? So if we will have like let's say a silo range of 16, which it says that like it will give us 64,500 like IP addresses and stuff like that. It's kind of like not applicable. So one of the details of the exam is expecting like for us to be able to optimize that IP usage for Kubernetes Engine based on the business assumptions we'll have or the business requirements we will have over there. So if that one is something that's like, you don't feel like very confident, I would say, there is also a video over there on the bottom of the slide. So make sure to check out that video for more details. Now, this is kind of like the example that we want to have a look. So if the question asks us like, what is the optimal size for a JKE cluster with up to 4 nodes and up to 110 pods on each of them? So we need to know the rules and then to make a kind of like calculation in our head, because we can't use any material on the exam, but although the calculation, right, it doesn't need to be like very precise. It's kind of like for us to kind of know the ballpark figure as well. I have been told that these questions are on the exam, but I have not have a question about this, to be honest with you. So I don't remember having this one. So they are covered, but probably it's just a few of them, and it all depends on the luck as well. So yeah, there's a couple of details over there, which says like over there, like, oh, if it's the maximum, what are we talking about? The maximum 4 nodes, but up to 110 pods on each of them. So what will be the optimal subnet size for those nodes? Private clusters, they are definitely a best practice in Kubernetes Engine. So you can think about them in a similar way to the managed instance group, but without external IPs, right? So once we deploy the private clusters, we still need to decide how to access the control plane. And if our cluster nodes need to access some GCP services, like let's say like a Google Cloud Storage, we will need to enable private Google access. So just like we would do for a normal VM. Now, in my part for now, which we are almost an hour going on this one, we have another diagnostic question to talk about. So your team needs to create a Google Kubernetes Engine cluster to host a newly built application that requires access to third-party services on the internet. Your company does not allow any Compute Engine instance to have a public IP address on Google Cloud. You need to create a deployment strategy that adheres to these guidelines. So what you should do? So what do we need to do, right? We need to create JKE and JKE cluster and to host a newly built application that requires access to third-party services on the internet. But it does not allow any Compute Engines to have a public IP address. So would you configure the cluster as a private cluster and then configure private Google access on the VPC? Would you configure as a public cluster and then disable external IPs on each of the cluster nodes? That is B. C, configure the cluster as a private cluster and configure Cloud NAT gateway for the cluster subnet. Or D, create a Compute Engine instance, install a NAT proxy on the instance, and configure all workloads on JKE to pass through this proxy to access third-party services on the internet. Someone says D. C. So what is I'm wondering, like, what is the rationale about D? Because our company does not allow any Compute Engine instance to have a public IP address. And if you have a NAT proxy and you configure to pass through this proxy, do you need a public IP address? In my calculation, I think you need, right? So the answer will be C. So you would configure it as a private cluster, and then you will have a Cloud NAT gateway for the cluster subnet. So that means that you will not have a public IP address, but you will still be able to access that third-party services on the internet. Awesome. Now, that is the part where we have the first part when it comes to JKE mostly and everything. Stefan will continue with the second part, but I was wondering if we should have 5 to 7 minutes and we come back on the top of the hour. What do you think?
Yeah, same thing. I was thinking 7 o'clock. We can kick off with the
Awesome.
second part.
Perfect. Sounds good. Awesome. Well, everyone, I don't know about you, but I will go and grab tea because why not? And I'll see you all in 7 minutes.
Cool. Amazing. Hope everyone had some tea, a drink at least, and we're ready to kick off with part 2. Gonna speak a bit about containers, not the ones that you see them on the ships, but Docker. Although the logo does look fairly similar. So now that we move from cluster networking to containers themselves, well, when building images, efficiency is key. So as you can see in the diagram, every instruction in your Docker file, like copy or run, creates a new layer. So these layers are read only and stack on top of each other. The final container just add a thin read-write layer on top. And the best practice here is to keep your base images small. So using something like Alpine instead of full OS like Ubuntu, it's much better. Why? Because smaller images mean faster downloads, faster scaling, and smaller attack surface. Another crucial strategy mentioned in the exam tips, it's using multi-stage builds. So this allows you to compile your code in a heavy build container, but only copy the final binary into a lightweight runtime container, discarding all the build tools and clutter essentially. Also, try to order your Docker file instructions so that the common layers like OS updates or dependencies are at the top. This minimizing this method would essentially minimize caching, meaning that if you change your app code, Docker doesn't have to re-download the OS layers. And just to conclude on this bit, think of an image building of packing light. Use minimal based images. Minimize the number of layers by chaining commands, and use multi-stage builds to ship only what's strictly necessary for the app to run. So now we're going to move forward for the ingress service. So standard versus non-NEG versus NEG. We do have a comparison here. We do have some load balancers. So just going to have a look a bit through this. So let's compare the two ways traffic can reach your pod. So on the left, we do have standard legacy method using instance group. Here, the load balancer sends traffic to a node, essentially a VM. And then the node's internal IP tables rules act as a second router to find the correct pod. So this often results in a double hop. Traffic hits a node that doesn't hold the pod, gets forwarded to another node that does, and finally reaches the app, which adds latency and complexity. Just to understand here, it's essentially like you're going through two roundabouts, let's say. So instead of going straight away on your exit road on the motorway, or whether you're coming onto the motorway, you're going through two roundabouts, and yeah, essentially that delays you. This is the easiest way to understand this. So on the right side, we have NGs, also known as network endpoint groups, also known as container native load balancing. So with NEGs, the load balancer is aware of the individual pod IPs, not just the VMs. This allows traffic to bypass the node level proxy entirely and travel straight from the load balancer to the container. And here, as an exam tip, this is a preferred method, so the one on the right side, because it improves performance, supports advanced features like gRPC. So if gRPC is a very interesting one, and if you don't know it, I would definitely recommend you to have a look at this. And what I meant to say, features for gRPC and allows load balancer to help check the actual application rather than just server hosting. This gRPC, it's when I've discovered it, I was absolutely amazed. It compiles to binary. What was it? You do have, in my opinion, it has an extra layer, but realistically speaking, it doesn't. The gRPC, it has a proto, a specific configuration file. I think it's .proto, and you do have to pay attention over there when you configure that. But essentially, gRPC, it's amazing for microservices, essentially. So just to conclude on this, it's the NEG essentially removes the middleman. So instead of routing traffic to a server and relying on IP table to deliver it, NEG is allowed load balancer to deliver traffic directly to the application door. That's just what to remember from this. Just to moving to the next one. So we're just gonna look through now. Essentially, you build a container, and you see like there's quite a lot of commands in here. Most probably, you wanna build one into a cluster, let's just say. So Kubernetes can be configured with many options and add-ons, but can be time consuming to bootstrap from the ground up. So instead of bootstrap Kubernetes using Google Kubernetes Engine, you can start up Kubernetes on a cluster in GKE. All you do is run the command that you see it on the screen, which is gcloud container cluster create K1. This is essentially the easiest way, and at this point you should have a cluster called K1 configured and ready to go, and you can essentially just check this on the console. So just to mention a bit about the the commands. So it can be quite easy to mix this, and especially on the exam. So you need to distinguish between managing infrastructure, which is the cluster itself, and managing the objects inside it. So if you are creating a cluster, resizing the number of nodes or enabling or auto scaling on a node pool, you are changing the Google Cloud infrastructure. For this task, you must use gcloud command. On the other hand, if you're interacting with Kubernetes objects, like deploying pod services or scaling a specific deployment of your app, you're working inside the cluster. So for these tasks, you use the standard kubectl command. So you can see it in those examples here. Obviously, as usual, we will send forgot the name. The slides. We will send. You'll have the slides in your inbox, but feel free to take some screenshots if you want. It's very important to make this distinction here. So just as a conclusion on this bit, think of it at this way. G-Cloud builds the house, the cluster nodes, and kubectl arranges the furniture inside the pods and essentially the services. I know I've been terrorizing you with loads of analogies, but I generally hope that my analogies will help you on the exam. Next, I think we're gonna speak about yes, scalability dimensions. That's fine. So this is essentially on this slide. It provides a conceptual grid for thinking about scaling in GKE. So we divide scaling into two layers: the workload layer, your pods, and the infrastructure layer, your nodes. There should be. I think this slide is slightly off because we should have the workload at the top and the infrastructure at the bottom. There you go. Yes, sorry. That's why I couldn't find it. Thank you. So we divide the scaling into two layers: workload layer and the infrastructure layer. So on the horizontal axis, we have scaling out, adding more pods or nodes to handle traffic. And on the vertical axis, we have scaling up, increasing the size of the individual pods or nodes to handle heavier processing tasks. So the most critical takeaway here is the writing in red. So here is essentially where you actually save money. Referring to the infrastructure layer, you can scale your pods down perfectly, but if the underlying nodes stay running, you are still paying for that idle compute capacity. So true cost efficiency comes from automating from bottom layer using cluster autoscaler to remove empty nodes and node auto provisioning to ensure that you are using the correct machine size. I think we've been speaking about this we've been mentioning this quite a lot, especially looking after costs. So to conclude here, workload scaling ensures that your application is fast. Infrastructural scaling ensures your bill is low, and you need both working in tandem to run an efficient cluster. So both of them need to be together. Let's move on to the next one. So just building on the previous concept, this slides maps specific GKE features to our 4 scaling dimensions. So on the workload side, we have horizontal pod autoscaler, HPA, which adds or removes pods based on CPU or custom metrics, and the vertical autoscaler, VPA, which automatically adjusts the CPU and memory reservation for your existing pods to keep them right size. So these tools ensure your application stays responsive without manual intervention. So at the infrastructure level, we have cluster autoscaler, CA, and node auto provisioning. While the cluster autoscaler simply adds or removes from your existing pods, NAP goes a step further by creating entirely new nodes pools with the most cost-effective machine types for your specific workloads. As highlighted in red, these bottom row tools are primary levels for cost optimization, as they ensure that you aren't paying for ghost infrastructure that isn't actually supporting any active pods. So again, as a conclusion here, by combining HPA for performance and CA or NAP for infrastructure efficiency, you create a fully automated system that balances high availability with maximum cost saving. I think next we have some diagnostic questions. As Goran was saying, we can't do this without diagnostic question. Cool. So your company uses GKE as a platform for all workloads. Your company has single GKE cluster that contains batch, stateful, and stateless workloads. The GKE cluster is configured with a single node pool with 200 nodes. Your company needs to reduce the cost of the cluster, but it does not want to compromise availability. What should you do? Option A, create a second GKE cluster for the batch workloads only, allocate the 200 origin nodes across both clusters, configure CPU and memory limits on the namespaces in the cluster, configure all pods to have a CPU and memory limits, configure a horizontal pod autoscaler for all stateless workloads and for all compatible stateful workloads. Configure the cluster to use node autoscaling. Or option D, change the node pool to preemptible VMs. What should we do? C, some A, some C. C, okay. Cool. So, drum rolls for this one. Yeah, so autoscaling, the correct answer is yes, C, or the third A. Let's just put it in this A. Autoscaling workloads and the node pools makes your whole infrastructure more elastic and gives you the option to rely on the same node pool. We're not going to discuss about the other ones, just in the interest of time. Just going to move to what we have next. GKE bin packing. Okay, so this is a process of ensuring your workloads fit as efficiently as possible within your chosen machine size to maximize wasted resources. So, as the graph shows, different machine types like N1 standard 16 versus N1 high CPU 16 offer different balances of vCPU and RAM. So if your application is memory heavy but CPU light or vice versa, choosing the wrong bin, since we've been calling this bin packing, leads to paying for capacity you aren't using. So you can use node selector or node affinity to manually direct specific pods to the node pools that best match their resource needs. However, managing multiple nodes pools manually can become complex as you scale. So a much simpler and more automated option is to enable node auto provisioning, NAP. Remember, we were just speaking on the previous slide. So this monitors the resource request of your pending pods and automatically creates the right size nodes pools to accommodate them. So this eliminates guesswork of bin packing and ensuring that your infrastructure dynamically evolves to fit your application's actual footprint, rather than forcing the application to fit into a predefined server side. So it's like, how should I explain this? It's like one of those t-shirts that has polyester, and let's just say it will essentially, you just put it on and it will fit exactly on you, even though if you remove it, it doesn't look as big as or wide as your back, for example. So it's a similar concept. So a conclusion here would be that effective bin packing is about reducing slack, if you want it. So the gap between what you pay for what you use. So automating this with node auto provisioning is the most efficient way to maintain that balance, essentially. Next, I think we're going to speak about pod placement. So now that we understand how the right size of our infrastructure, we need to look how GKE decides which pods go onto which nodes. So to start with requests and limits, we do have like some categories we're going to go through. So requests and limits, request defines the minimum CPU and memory a container needs to stay healthy. And while limits acts as a ceiling to prevent single container from consuming all host resources. Following these basic resource rules, we use node selectors to pin pods to the specific node pools using simple labels, ensuring that specialized workloads like this requiring GPUs land on the correct hardware. So for more complex scenarios, we use affinity and anti-affinity, which allow for expensive rules based on the pod and node label. So for example, you might think that anti-affinity, you might use anti-affinity to ensure that two replicas of the same service never run on the same node to maintain high availability. So finally, we have taints and toleration, which work like lock and key system. Let's say a taint on a node repels all pods by default, and only pods with the matching toleration are allowed to schedule there. Which is, essentially, it's a great way to reserve specific nodes for dedicated system tasks or high priority tenants. So about the pod placement. So when we talk about this, the first thing GKE looks at is the resource specifications. So requests are the most critical for scheduling. They tell Kubernetes the minimum of amount of CPU and memory a container absolutely needs to run. So the scheduler uses request value to find a node with enough free capacity to fit the pod. So on the other hand, limits defines the minimum resources container can consume, while a pod can technically exceed its CPU limits. It just gets throttled, and memory is it's hard ceiling, essentially. So looking at this, looking at the examples on the slide, you can see how this implemented in YAML and how it appears in Google Cloud Console. So notice the warning at the bottom. If a container attempts to use more memory that its defined limit, it triggers out of memory. Yeah, so essentially this is a safety mechanism to prevent a single leaking or runway process from crashing the entire underlying node. So setting these values accurately is the only way to essentially ensure your cluster can scale effectively without constant stability issue. Where were we? Yeah. Okay, so for the pod, we're still on the pod placement on taints and toleration. So in the final piece of the pod placement puzzle is the system of taints and toleration. So while node selectors affinity rules attract pods to specific nodes, taints do the opposite. They allow a node to repel a set of pods. As you can see in the diagram, when you apply a taint to a node, pods withokubectl a matching toleration are blocked or even evicted. So you apply taints directly to the infrastructure using kubectl taint nodes, often with effects like no schedule or no execute, as you can see right at the bottom. So this lock and key, that mechanism that I've been mentioned before, is essential for dedicated infrastructure. So for example, the YAML snippet shows a web app deployment with toleration for a specific service web taint. Without this explicit permission in the pod spec, the scheduler will fail, as shown in the error message. You can see here that 3 nodes right at the bottom where it says failed. Okay, which they show that they didn't tolerate. So this ensured that your most expensive or specialized nodes are reserved strictly for the workload authorized to use them. So here, as a conclusion, it's this. Taints and toleration provide the ultimate control over node exclusively. So ensuring that sensitive or specialized hardware it's never polluted by general purpose workloads. So a key takeaway would be here that taints are applied to nodes to repel pods, while tolerations are applied to pods to allow them to schedule on tainted nodes. I know it's quite hard to it might be quite hard to get your head around this, but obviously we will share this thing again, and feel free to go over this knowledge. What do we have next? Service mesh. Cool. So finally, let's discuss about service mesh, specifically Istio and Anthos service mesh, also known as ASM. So as your microservices architecture grows, managing communication between dozens or hundreds of pods becomes incredibly difficult, and it's true. It can be quite of a headache. So a service mesh adds a dedicated infrastructure layer, a data plane, if you want to, consisting of network proxies that sit alongside your workloads. So these proxies, managed by a centralized control plane, handle complex network tasks like service authentication, load balancing, and telemetry without having to write a single line of networking code on the actual application. So the real power of service mesh lies in its advanced traffic management and security features. For outbound traffic, it provides the fine-grained routing and circuit breakers to prevent cascading failures. For inbound traffic, it handles authorization, rate limiting, and request tracing. So here, as the exam tip notes, service mesh is the right choice when you need high-level capabilities like mutual TLS for encrypted internal communication, fault injection for resilience testing, or traffic splitting for seamless canary deployment. So a key takeaway here would be to use service mesh to manage microservices, complexity to sidecar proxy architecture. So it provides advanced security, observability, and traffic control without modifying application code. Next, I think we have your favorites. Your favorite, because it's just one. Diagnostic question. So you have deployed an application on Anthos clusters, formerly known as Anthos GKE. Okay. According to the SRE practices at your company, you need to be alerted if request latency is above a certain threshold for a specified amount of time. What should you do? Enable the Cloud Trace API on your project and use cloud monitoring alerts to set an alert based on the Cloud Trace metrics. Install ASM on your cluster. Use Google Cloud Console to define a service level objective and create an alerting policy based on this SLO. Use Google Profiler to follow the request latency. Create a custom metric in cloud monitoring based on the results of the cloud profiler, and create an alerting policy in case this metric exceeds the threshold. Or configure this Atos config management on your cluster and create a YAML file that defines SLO and alerting policy you want to deploy in your cluster. B, D, second A. Yeah, love that. Well done. Yeah, so the drum roll. The correct answer is indeed B, or second A, if you'd like. So this is correct path, because ASM provides out-of-the-box telemetry for every service in the mesh. Because of the service mesh provides all traffic, it can automatically measure latency without any code changes, as we said. The Google Cloud Console then allows you to turn those metrics into SLO, and this is essentially an industry standard to track reliability and trigger alerts when performance dips. Cool. What do we have next? I think we have a few more, and we're pretty much done. Yeah, we did have quite a lot of slides to go through, but I think Goran and I have actually powered through this. We're becoming better and better every single week at this. Cool. So let's look at this. I love this. How should we call them? No graph. Schemas. Drawings. So let's look at this. It's an overview, let's say. So the GKE overview, it perfectly illustrates the transition from basic containers to a fully managed Kubernetes environment. So GKE bridges the gap between the developer's kit. We all know it works on my machine and production ready system by providing a managed control plane that handles the API server, scheduling and resource controllers across multiple zones for high availability. We discussed about this. The right side of this slide serves as a great review of our core pillars. You can see 4 scalability dimension. We covered HPA, VPA for workloads, and CA and NAP for infrastructure. Those working together to handle traffic growth. So underneath that, the security section reinforces our best practices, protecting the software supply chain with binary authorization, securing the network with private clusters and cloud. And cloud armor, and ensuring the data encryption. It's complete system designing to let developer focus on code, and essentially Google manages the heavy lifting of the infrastructure. So we do have a conclusion and takeaway here. Just use this visual as your mental map for exam. Take a mental photo if you want. If you can explain how a user goes from kubectl to secure auto-scaled app running on private nodes, you're essentially ready for the GKE section of the certification. But we need to look specifically how much we would be this. But yeah, I think it should be fine. So a key takeaway would be that GKE is fully managed service that automates the life cycle on Kubernetes cluster, including scaling, patching, and security, allowing teams to run portable containerized application at global scale with minimal operational overhead. That's pretty much here. Yeah, I think we're gonna move next to. We have a bit on Cloud Run. So just gonna actually, I think we could just gonna move on to the next one. Yeah, on yeah, there you go. So just a few words about this. What's Cloud Run and how it differs from App Engine. So Cloud Run is serverless Kubernetes. Since App Engine, I think, was released in 2008, it's obviously it's not Kubernetes. But the idea is the same. Cloud Run allows you to deploy an app and have it consumed without any sizing or defining the resources underneath. So Cloud Run differentiates with App Engine in being Kubernetes based, and it really does not have such restrictions for programming languages or libraries you can use like App Engine does. And since it's Kubernetes based, which are they're super popular nowadays. It can be used in many use cases. Also in those created, with microservices approach. So what's super important with Cloud Run, your workload need to be stateless. So App Engine and Cloud Run can be used in similar scenarios, but when we see the history, we'll notice that Cloud Run is a much more newer and more modern service that might even become a successor of App Engine in the future. So Cloud Run is managed compute platform that enables you to run stateless containers via web requests or PubSub events. Cloud Run is serverless. It abstracts away all infrastructure management. You can focus on developing applications. It's built on Knative, an open source Kubernetes-based platform. It builds, deploys, and manages modern serverless workloads. Cloud Run gives you the choice of running containers either fully managed or if you own GKE cluster, since we've been mentioning about this. So Cloud Run automatically scales up and down from zero, depending on the traffic, almost instantaneously. So you never have to worry about scale configurations. Cloud Run also charges you only for the resources you use. And this is important to note that this is calculated down to the nearest 100 milliseconds. So you never have to pay for over provisioning resources. So with Cloud Run, again, you can deploy your stateless containers with consistent developer experience to fully manage environment or to your own GKE cluster, as I mentioned before. So the common experience is enabled by Knative, an open API, and runtime environment built on Kubernetes that gives you freedom to move your workloads across different environments, and platforms fully managed on Google Cloud, GKE, or anywhere Knative runs. I think that's pretty much it on this bit. So on containers in GCP, GKE or Cloud Run? Okay. So the final decision you often face in GCP is choosing between GKE and Cloud Run. While both run containers, they cater to different operational needs. GKE is a robust orchestration platform that gives you deep control over underlying infrastructure, networking, and scaling. Cloud Run, on the other hand, it's a fully serverless product. It's designed for time to market, if you want to call it that way, allowing you to deploy an image and have it scale automatically to 0 or to thousands without managing any clusters or nodes at all. So for the exam, remember that key differentiator is operational overhead. Choose Cloud Run if your priority is fast development and you want to remove all infrastructure management from your workload. Choose GKE if you need complex orchestration, custom machine types, or specific networking configuration that serverless environment don't support. You can see it here in red. 90% of new Cloud Run users are able to code, build, and deploy an app within 5 minutes. That's good. So if you want to manage a cluster, pick GKE. If you want to run a container, pick Cloud Run. So a key takeaway would be Cloud Run is fully serverless platform optimized for speed and zero infrastructure management, while GKE is an orchestration platform optimized for control and complex multi-container workloads. I think that's pretty much it, what we have for today. We do have 15 minutes left anyways. I think we do have a case study here, analysis, but I'm not 100% sure. I think this should be as a homework, or maybe should we do some diagnostic questions and leave from this case study and leave them for as a homework? What do you think, Goran?
Yeah, so the case study, I would say we won't go now just because to kind of like give them the details, right? You have the
Mm.
link over here. So there is a proposed technical solution, stuff like that. But there is also some diagnostic questions with answers over there that will help you on those parts. So what we'll do is we will not actually go through them, as you mentioned,
Yeah.
but just wanted to raise that at the end we have the optional materials that everyone can go through on those sites. And as you always know that we have the Google Cloud Innovators if you sign up over there. So now they changed that, right, on those kind of parts. I think no longer accepting, but if you would go and sign up right now, you will get, I think it was still like a 35 credits, right? Or something like that. I know there's been like a transition period over there and the arcade. Those are like all the details. But I think probably they are, at the end of thinking. So I don't know if more diagnostic questions will be good at this point because it might, not bring a lot of value. So what I would say at this point is probably we should.
Should
I
we
want
call it
to.
a day? Because we kind of
Yeah.
quite a lot of information, and I think this session has been like quite specific, rather than the ones that we normally do. Yeah, I think we should just call it a day.
Yeah. Yeah.
Give them. I mean, we always take a lot of their time, so 14, 13 minutes we can give them back. We have provided with the emails in case you need any support or missing. Yeah, I'm literally looking through the chat and I can see like 606 you have been posting that. Next week same time. Yeah, okay. Do it again. Connect with us, reach out, keep an eye on the platform because we are cooking, we're working on some events, so hopefully we might see some of you in person if you are based in London. And yeah.
Awesome. Yeah, I would say as well. Well, everyone, please look out for the email coming up from our side with the recording and the slides. And have a great evening, and I'll see you next week. Take care, everyone.
Bye.
Bye-bye.